Hello, everyone. Hope everyone is having a great time with Codemotion. It's the second day, and we had a great talk, a keynote to begin with. And thank you for joining me. My name is Teresa. I work for JP Morgan. And on the side, I'm also quite active in the community. If you are familiar with the Google community, I'm a part of the GDE group, Google Expert Developer Group. So topic I'm going to talk today is about DevOps, but mostly for front-end project. Although I couldn't see everyone's face, it's a bit dark from this side, but please let me know if you are front-end engineers. Thank you. Wow, awesome, awesome. And I hope you're enjoying the talk today. And if you're not coming from the front-end side, I still hope you can enjoy it. I will talk a bit more about the project architecture and how DevOps is implemented in front-end project. As for myself, I work as a software engineer, but mostly in the front-end world and in fintech industry mostly, even before I joined JP Morgan. And for many years, actually, I've been struggling with the team of unreleased pipeline and how can we accelerate this process. So those things are things I've been worked quite a lot. Mostly, recently, I've been working in the dev experience team, in the infrastructure team, and the platform team as well. So we did a lot in our product in JP Morgan Chase and in my previous fintech product as well to improve how we can do the release and how we automate things. So I'm going to talk about here today about my personal experience to share with you things I've learned and to show you how we actually do this in our own product. So yeah, let's begin, right? We will have quite a few things to cover today. I will start from giving you a brief of DevOps in case you are not familiar with this field. And I will dive into the CI/CD and the pipeline for frontend and to give you from my own experience of things we can do to improve it. But then I will also dive into front-end, showing you the architecture of our project and how we actually implemented those things step by step. And in the end, I will talk about release, which was very interesting, and it's probably a pain point as well, especially for front-end project, because we work a lot with UI. And for example, if we work with web app or with mobile application, how we can release the process are quite different, especially for mobile applications, because everything has to go through the Play Store, the App Store. So afterwards, hopefully we'll have, a bee. In the end, we will have some time for questions, right? So let's kick off. So let's talk about DevOps first. DevOps, this word was actually a new word, right? It's not English word. It was innovated. So back in 2007, Patrick, actually, he realized the frustration of the soils between developers and operations. In old time, what happens is the engineering team, the develop team will spend months or maybe a year to develop a product. And in the end, they will just throw the code, maybe like 1 year of work or at least 6 months of work, to the operation team saying, there you go, right? Release it and package it and release it. And operation team will then go through the process to test, to bundle, to pack this product and push out to the end user. See the frustration here, right? If something goes wrong, right, and we don't actually detect errors early in the process. This is why a year later, also along with with Agile and DevOps work really well together. In a way, DevOps implemented a lot of good concepts from Agile. So this was discussed in a meetup in Agile and to gather ideas. And then through the year, DevOps become actually a name for its own. in this way, like about 12, 13 years ago, there's finally a very confirmed, published DevOps right over those years, and it got officially a name, and we're starting to see its impact in the industry. Right, as from a big picture, as overview, if you work in the DevOps industry, right, doesn't matter if you're on cloud engineering, for DevOps team, for backend team, if you're working on a very mature product, I'm sure you have someone in your team to maintain DevOps, right? Even though they're probably not wearing the hat of DevOps, someone in your team must be maintaining this automation process. So overall, DevOps team or this engineering, they're looking after development, operations, and quality assurance. And they look to bring the culture to collaborate, to communicate, to automate things, right? So we don't have to do things manually and repeating those manual work. And we look at how to make things continuously develop, continuously release, and integration. And we're looking for lean, right? Lean code. The benefit of that is we can accelerate our process, right? Because everything that we build, if we don't release them to our end user, even though we build an amazing product, amazing features, and if we don't release them, don't ship them, those are stock in our warehouse. And over time, it will become our burdens, right? So we want to push them out. And this is what DevOps is actually focusing with. But the thing is, right, I'm not going to explain you this picture word by word, but in terms of, as a front-end engineer, when we look at DevOps and look at automations, right, most of the study book, the textbook, and information that we can find is how we build DevOps. From a very big picture, right, talk about machine, talk about setting up a cloud, talk about Kubernetes, containers, right? But it doesn't really necessarily mean we could, I mean, we use them as for big picture, but if I simplify this a big, nice picture, right? The pipeline actually for our product, right, for backend or for frontend, are actually very similar, although we use different technology within each step. We get the code, right, from GitHub or from our source code. And this code is there waiting for actions. That's what we call the build triggers, right? It's a pull request or release process. And after we're building it on the machine, this image will be pushed to a container registration, and then it goes through the testing process and to our end user. For backend engineers, the end user is us, right? Front-end engineers. But when we look at DevOps for front-end project, the role is similar, but a bit more specifically for front-end product. Because as we're saying, is for front-end project, we deal with UI a lot, and our product will directly interact with our users. So this makes a big difference, right? A huge difference from front-end project comparing to back-end project. So for front-end project, from like a big picture overview-wise, DevOps, right, if you have this role in your team, they will be looking after the setup of the CI/CD pipeline, the configuration. Either you do this manually or you outsource this to a third-party tool. We're also looking after automation, the process, right, build, test, and pack the project. And we configure the tool. We also bump the version of the app, either manually or we automate this process. We also look after the application release management. And afterwards, we also look after monitoring as well to get feedback. So we can then get this gathering the feedback and start the loop again. So to simplify this picture, right, and this applies to most of the project, it starts from getting the code, right, and going through the process of build, testing, deploy, and then goes back to monitoring, and then make plans. And then this plan goes back to the second iteration of the code again. So how we implement it in our product, in our front-end product. So this is, again, a brief picture of it, but I will talk about those steps a bit more in detail in my following slides. We have Git, right? We have different multiple repository. We do have our main repository, and we do have other libraries that we build to support our product. So our code is actually, we get the code from different repository. We put them together, and we set up a webhook for our CSD tool. And this webhook will check for our commit if it matches our standard, our policy, right? That this commit have for example, a code owner approval. Does it have a ticket number? Is the code clean? Do we have enough coverage for test, right? So we do have lots of checks in this case. And again, depends on how you build your pipeline, and depends on the scale of your project. Maybe you are working with multi-branch. Maybe you have a scheduled job on demand. You can create all those things, right? Doesn't matter which tool you use. And we build the project. This will be sent to Docker or to artifacts. And the testing team will starting to test it. Also, we do actually a lot of testings, right? Manual, automation, accessibility, UI, end-to-end integration, you name it, right? We do all of them. And the result will be sent by notification. Either it's a green, that means pass, or red, that means something is wrong, we need to fix them. And this will continue, right? So every time when we do our pull request, when we want to go through release, when the code is merged to the main branch, we do have those automation pipeline to check every step. And those are the tools, right, we can use for front-end project. And there's probably more, but those are I would say, the mainstream, the major product. I don't work for them, I don't advertise for them, I don't get money from them. I just share my experience of, like, I use some of them. Jenkins, for example, GitHub Action is probably very popular. And if you work for multi-platform, especially if you work for, like, with Flutter, you can try Codemotion, or Bitrise is actually very popular for mobile applications. And they do pretty much very similar thing. You can build everything yourself, right, in-house of all the pipeline. Also, you can use those tools. They automate a lot of functions for you. For example, get the code from your repository, doing the checks, and then push the code to, for example, if it's for mobile application, push the code to the App Store. Right, how do we choose our tools, right? Like, when we decide which tool to use, for example, we can use Jenkins, where we have to do lots of manual things, but it's actually quite cost-effectively. So think about, like, if it's the cost, how we integrate those tools. Is it security use? What is our security requirements? Can we actually push our code in a third-party cloud host, or do we have to host everything locally? How can we scale it if the project grows? And if I choose one tool, right, this is actually one of the most important things in my opinion, is can I migrate later to a different platform? Because I don't want to stuck in one platform forever. Is it easily that I could integrate to a different platform? And how do we host them, right, locally or on cloud? And okay, so we talked about DevOps as a big picture, and a bit of dive in how we create DevOps as a flow in our product in JPMorgan Chase. Now let's dive into the actual pipeline implementation. And there's a study and a book by Google. They actually mentioned about different type of pipeline, and this is information actually summarized from that a long article. You might use all of them, maybe not, it depends, and I will go through each of them one by one, and I'll talk you through of what we did in our project to improve each of those type of pipelines, right? So we have integration, we have a full, we have release, and deployment. And each of them does different things. So mostly, right, you probably have integration. That's where you run your pipeline to merge your code. And the release and the full might be one pipeline in some cases, right? Depends on how you build it. And the deployment is the most secure pipeline in this way that you don't want to interact it a lot. It should be triggered when you're ready to push the code to the App Store or to your image registration, so it goes to your end user. Okay, so when we're starting building those pipelines, right, there are lots of challenges, right? Those are our pain point, maybe yours as well. It's taking too long to run a build, especially when we want to merge our code. And what do we mean by too long, right? It might be taking 20 minutes, maybe 50, maybe an hour, right? It's too long, basically, especially when you have a big team with, I don't know, 50, 100 engineers who want to submit code every hour, because everyone is working really hard, right? And do we implement fail fast, or we don't implement a fail fast? What this means is, for example, I have a pull request. I want to merge my code to the main branch. And when I started to run the testing pipeline, there's one failed test in my pipeline, and what should I do with it, right? So these are up to discussion, and up to your team to decide, right? When I run into the first failed tests, I fail the entire build process and give this feedback to engineer team saying, there's a build fail, fix it. It will be very quick in terms of feedback. You might see this error in 5 minutes, so you can start fixing it. The disadvantage of this is, for example, the engineering team get this notification, they fix one test, submit the pull request again, and after 10 minutes, they might got another build fail because another test failed. So they have to fix this again. In comparing to if we don't have fail fast, we run the whole pipeline for like 25 minutes. We see 4 tests fail, and we fix them together and run them together. So which one you choose to use, depending on your team and up to discussion, right? They have their own benefits and their own disadvantage. Again, which tests to run, I will discuss this a bit more. Do we use caching? Because it's actually very, very powerful, and how do we use caching and where, right? And again, one of the pain points I heard from the product team is the notification is kind of ignored. If it's not about my PR, if it's a failed tests on someone else's branch in a different pipeline, those information are lost, right? And who is the one to pick them up? So those are the pain for pipelines, right, for DevOps in our front-end project. But how do we solve them? Because in front-end project, we also have our own challenges, right? We need to think about what to test or what not to test in each of the process, right? Because you don't want to do too much in the build process. For example, do we do end-to-end test in PR, right? We have long-lived release branch, and fixing bugs in those release branch delays our release cycle. And taking too long to merge PR, yes. And our project, right? We have multiple modules in our project. We don't have a monolith project. This is nice to build with a project that has different modules, different packages, because each team can own their own module, their own package to begin with. But when it comes to release process, right, suddenly our project become a monolith project again, because we can't ship them individually. We have to ship them as one big project. So there's circle dependencies, then the project is monolith. And we have errors which are not detected and alarmed and notified. So how do we put this all together, right? So I will start with project architecture, monorepo, monolith. Those are the pain points we have. And those are the key areas we worked with to improve our release process, to improve our DevOps experience. And because for front-end project, the CI/CD pipeline associates a lot with how the project is built. So we're starting to address those pain points, and we look at them and fixing them together with improving our pipeline. And to dive in a little bit, when it comes to integration, this means to merge our PR, and usually, ideally, right, it should take 10, 20 minutes-ish. And in your project, how long do you take to merge your PR? Is under 10 minutes? Under 15 minutes? Under 20 minutes? Over an hour? Anyone? Okay, I'm sorry for this pain. I hope you can actually get some of the ideas today and implementing back to your project. So yeah, over an hour is really, really painful. Yeah, in reality, we do have these cases, and that's how we actually start with. And we improve a lot, really, through the years. So I've talked about those few things already in my previous slides, like fail fast, PR, and code owner, right? So I will dive into what we did to improve this process. So begin with branching strategy, right? And what do we use, right? Do we use Git flow? Do we use a trunk? Do we use scale trunk? And how does it impact the pipeline, right? So sometimes we think we're using trunk, right? Hands up if you are using trunk. Nice. Actually, I think trunk is actually a very good methodology. That means you actually following the extreme project design. Ideally, when you use a trunk, you don't have to make pull request. So if you have a pull request while you're building trunk development, that means you're probably using scaled trunk. With trunk, you probably can do pair programming, and you code. And for example, you do pair programming, you test everything locally, and then you merge your code to the main branch, right? You don't have to create a feature branch, you don't have to create a pull request. Everything goes back to the main branch straight away. The only thing that you branch out from your main trunk is when you do release. But on the other hand, we do Git flow a lot, especially for front-end project. We do have lots of different type of branch. We have a main branch, we have a develop branch, we have hotfix branch, release branch, you name it, right? And the feature branch. So we begin with having Git flow, and we want to slowly go into trunk because we do see how it can actually improve our process. So we are somewhere in the middle. This is a scale trunk. So we do have a main branch, and we have feature branch for people to review the code. And we merge everything back to the main branch. So it's actually a bit improvement already from where we begin with. And testing strategy impact a lot on your pipeline design. What do we test in each step, and what we don't need to test, right? Ideally, this is just like from own experience, right? When you do your PR, when you do your code integration, you definitely want to run unit test, check your test coverage. For example, if you have like 80% threshold, make sure that each code merge doesn't impact this test coverage, doesn't reduce it in a way. Do your lint check, your security check, but don't do too much, right? So that should be enough. When you are doing a release or running full pipeline, you can do more. For example, your accessibility test, your API test, your UI test, integration test. Questionably, you can do integration in PR or in the release or in your full pipeline that we actually run in the nightly. So it's in the peak hour, because each of the nightly build takes about 2-3 hours to run, because we do the full test in the off-peak hour. Sorry. While you're reading this picture, I'm going to have some water. having your test separate is the key, right? You can do BDD, that's awesome, or you do TDD, or you do both. Nice, right? But think about how you design your project and how you do test within your project. Have a clear definition of each type of test. This will definitely improve a lot for your pipeline. So when you pick up unit test, right, you don't have to pick up everything. Ideally, you can run unit test only in the affected area. So if I submit one line of code in one module, I can just run unit test in that specific package, including, of course, everything that, all its dependencies, right? All these packages that has dependency with, but you don't have to run unit test in the whole project. So in the end, our integration pipeline, PR pipeline, will look like this, right? We get the code, we set up configuration, we do code analysis, right? Check if everything is secure. And then we start to run those jobs in parallel. We don't run them in async, so we run them in parallel. Then we do code validations, right? Linked, security, and sanitize the code. We run unit test, and we check the test coverage. And the PR will fail if the test coverage is below the threshold, or if this code merge will actually decrease our test coverage. We then fail this PR, saying to the developer, take a look, right? And those are the areas you need to concentrate. And we do some integration tests, some UI tests, not a lot. It's like mostly on a smoke test level to check everything work as usual, but we don't go in deep to test all the journeys here. We just make sure that UI fire up and this code change doesn't impact the UI to load. That's it, right? So like this one will be like a minute, no more than 5 minutes. And then we load this build to artifacts and also together with the test result and send the notifications. And I'm running out of time, so I need to go a bit quicker. You might have a full release pipeline that we do in a nightly build, or you just have one release pipeline that you trigger when you're about to push your code to your end user. And this pipeline does run slightly longer, and it's okay because the responsibility of this pipeline is to run all the tests, right? So that's why we pick a nightly build to run this in the off-peak hour. And there are a lot of things you can do. Starting from analyze your project. If it's monorepo or multi-repo, it's nice to work with monorepo project, but it's also okay if your project has multi-repo. Depends on the scale. It shouldn't impact that much of how you design your pipeline. Just make sure that you know where your code came from. And we do have this process of code owner in our pipeline. So the code owner of this module, of this project, of this monorepo repo, has to approve, to check this code to make sure everything works as expected, right? We don't change the product feature. We don't change what is in a released already. And is our project monolith, right? As I was saying, maybe when we build our project, we have multiple package and multiple modules, right? But on release level, we still have to bundle everything together as one whole project. And this will actually delay our release process as well. And which framework do we use, right? Do we use React? Do we use Angular? Do we use native, iOS, Android? Or do we use React Native or Flutter, right? Do we use multi-platform framework? This will also impact how you design your pipeline as well. So I will talk a little bit more about release pipeline in case you're having them as one type. Our nightly off-peak time build is actually probably the longest pipeline we have. Again, as from a picture overview, we get a code. We again do code validations, right? And the difference in the full pipeline is we run all the tests that we have, including unit test and smoke test, API, integration, end-to-end, accessibility, you name it. And then we give the build result in Artifactory and give this report back to engineering and the product team for everyone to take a look of what we've done, right, through today. So we do have a separate pipeline for release. This is where we cut the release branch, right? The time it takes to run this pipeline is actually the same as our off-peak time pipeline. But what will impact the design of this pipeline is your release management and the process of you to plan, to design, to schedule, and how you control your release process, right? How often do you release or deploy? If you do agile, right? For example, it could be releasing every 2 weeks, for example, or every week, or even every day, right? That's awesome. And how do we fix bugs on release branch? And in our project, we're following the theory and the design of micro-frontend. That means at the build time, we have multiple modules, right? I'm going to give you a number of it. We have 70 modules, 70 packages in our project. This is what we split the project in build time. We also release our project in this way as well. And how do we do it, right? We implemented auto-versioning. That means each package, we can actually build them independently. We can actually run pipeline for this package to release this package independently. We also version it automatically as well. So this, when we build a release for this package, we auto-bump the version of it, and the new version will be updated through the package.json for other modules to use as a library. We automated this whole process. That means we actually don't release a project as a big project, right? We do in the end, but we still release in a smaller chunk, and we version them. So our product for each feature team can be consumed as a library for other team, right? So it's optionally. You can either use a package by version because it's being tested and versioned. Or if you want to work from develop branch, you can still use this package as from workspace, right? From the latest develop code. And caching. This is like one of the very nice feature we added in our project. This improves our testing process and our pipeline a lot. And what it means, we did 2 things here. First, as I was saying, our project is quite modularized, and we have different type of tests, very clearly defined in each package. That means when we trigger the build, especially when I only changed one line of code, maybe added some new features, I don't have to run everything together. So we have 70 packages, and we have like 1,000 unit tests. If I want to change just one module or add the new code to one module, I run the code in affected area. This means my own module and everything that has dependency from it. So I don't run 100% of the project. Maybe I run 30%, 40%, or even 20%, right? Depends on the dependencies of your code and how you impact other modules. We also cache the result of our tests. So we use a library here. I'll share the name. And so by caching means when we have this test result from this package, we actually hash code this result. And if I make a change for same package, this hash is invalid. That means I have to rerun this package again. But if I don't change anything in this package, the hash stays and it's still valid. That means I wouldn't trigger a build for things I didn't change. Also, we refresh it, right, when it's when it's getting old, right? 5 days, 10 days. And because of this, we actually utilize the power of micro-frontend, especially in our release process. We can actually release module when it's ready. So each feature team has the power, their decision to decide my product feature is finished, I'm going to release it. Or I want to put it behind the feature flag. It's not ready to use yet, so continue to use my code in front developer branch. So the power is back to the engineering team. Then we shift the test to left when we test the things early, and we can release on demand. We can also roll back to a previous release, right? Either to fix this bug on the release during the release process, or we can roll back to a version that doesn't contain this feature, which might causing a bug. So in the end, we did enhance our release cycle. We're able to detect error early. We separate release and the deployment, and we shorten our release cycle with automation. That means we could actually release 100 times a day, although we don't have to push the code out to production, but we can actually continue releasing our product. So the pipeline design is actually very similar to the full pipeline design, and the only thing here, extra, is how we notify people. Which group do we notify, and do we bump the version of the module here? That's the probably only difference, right? So the bump version of releasable packages. So with all this together, in the end, our secure deployment pipeline becomes really simple because it doesn't have to do too much, right? The only thing it does is to, because everything is tested, everything is sanitized, right? This pipeline is basically not accessible by engineers, right? It shouldn't, it's protected. And the only thing that this pipeline does is to receive a trigger and build the bundle, sign it, and push out to our user. So very simple, right? We get the code. Here, it's optional if you want to do test again. So you can maybe again. So maybe your release pipeline is combined with your deployment pipeline, so that in a way you probably want to run test again. But if we did a test already in our release pipeline, for the deployment, we just get the code and update the application version. So if you work for mobile applications, you might understand what it means, right? Because we might version our modules, for example, 20.7.0, and the application version is different. So this is how we actually, this is what the user will see, where they will see the updates. So this application version is actually one for our product, and you should actually synchronize this version between your platforms, right? Your iOS and Android app should have the same version. It's easier to manage. And we make the build, it goes to production. And that's it, right? And it distributed, and our users will start to see our product. So what we can do, right, to actually improve and enhance this even further, keep your repository small and delete branches that it's merged or you know you don't need. So you don't end up with like a repository with 1,000 of branches, right? And always remerge, always rebase before you merge to your main chunk. Even if the code doesn't have any conflict, right? But some people might change the code and you change it in some other area, although there's no code conflict, but you might actually impacting similar features together without even knowing it. So rebase, right? And think about running very large build in off-peak hour, so you save the computing power for the important jobs during the day in the peak time. And we have code owners who will, code owner is not the one person, right? It's people who know the product in this area. So they will actually have a look of when some other people push code that impact your area. You want to take a look, make sure those change that impact the existing features, change the user journeys, and introduce Git hook to check your code, pre-commit, post-merge, and check your commit message as well, because your commit message will probably become the release nodes in the end. And just continue to improve your pipelines, day by day, weekly, monthly. And thank you. And this is all I'm talking today. Thank you for joining me.
Thank you.